In the last section, we worked with the standard normal distribution, right, where the mean is 0 and the standard deviation is 1. Of course, most normal distributions don't have those values for the mean and standard deviation, but we can still use that table in all kinds of applied examples. And the way we do it is we're going to use this formula for a z-score, and we're going to be able to translate questions about our normal distribution that we might be working with to the standard normal distribution so that we can use the table. So in example 108, we're working with IQ test scores. They're normally distributed with a mean of 100, and the standard deviation is 16. So we know that mu is 100 and sigma is 16. And they've asked the question, if a person's picked at random, what's the probability that his or her IQ is between 100 and 115? So I'm going to start out the way we start out all of the problems in the last section. I'm going to draw a normal curve. The mean is in the middle. And here, our mean is 100. So I'm going to put 100 in the middle. And below that, I'm going to write the z-score. I know that 100 has a z-score of 0, right? Because it's exactly equal to the mean. Its distance from the mean is 0. And so I want to know what is the area between 100 and 115. What's the probability that the IQ will lie between these two values? So I know the z-score for 100. What I need is the z-score for 115. And if I can do that, then I know I can phrase the problem as what's the area between these two z-scores, and that's what's going to allow me to use the table. So let's find the z-score for x equals 115. So the z-score formula is x minus mu over sigma. So this is 115 minus 100 divided by 16, or 15 over 16. Now, we have a z-score in terms of this fraction, but we need it in terms of a decimal, and we need it in terms of a decimal because that's how our table has it. Our table uses z-scores to the nearest hundredth. So when we find this decimal, when we do the division, we're going to round it to the nearest hundredth place. So 15 over 16 is 0.9375. Rounding that to the nearest hundredth gives us 0.94. So now I know that I want the area under the curve between 0 and z equals 0.94. So originally they asked us the probability that the IQ score, the x value, is between 100 and 115. This is the same as the probability that z lies between 0 and 0.94. And since we're looking for the area between two z-scores, what I can do is use the table, find the total area to the left of the z equals 0.94, right? All of this area. And then I need to subtract off this area. Now we don't need to use the table for that area because we know that that's 0.5 because of the symmetry of the distribution. So using the table, we're looking up a z-score of 0.94. Here's 0.9. The 0.04 column gives us 0.8264. And so doing the subtraction would get 0.3264. And that's the probability that a person selected at random has an IQ between 100 and 115. Continuing on with the IQ example, remember the mean here is 100 and the standard deviation is 16. We want to find the probability that a person selected at random has an IQ greater than 90. Here's our standard normal curve. An IQ greater than 90, well, here's 100. The 100 is the mean, so that's right in the middle, and so 90 is a little bit below that. An IQ greater than 90 means we want this area right here. So we are looking for the probability that x is greater than 90. Our x values being the z-scores. The x values being the IQ scores. So what we want to do is translate this into a statement about z-scores. And to translate x values into z-scores, we use the z-score formula. So the z-score formula is x minus mu over sigma. Our x value is 90. And so 90 minus 100 is negative 10. Divide this by 16. And we get negative 0.625. Again, it's a z-score. We have to round these to the hundredths place, so we're going to call it negative 0.63. So there's our z-score. So 100 we know has a z-score of 0, 90 has a z-score of negative 0.63, and so now we want to know what's the probability that z is greater than negative 0.63. Now that's the area to the right of a given z-score, and our table will only give us areas to the left of a particular z-score. So we could use the table to give us this area right here if we look up negative 0.63. And if we do that, then all we need to do to follow up is subtract it from 1. So negative 0.63 here's the negative 0.6 row and the 0.3 column. Well, let's see, this is negative 0.60, negative 0.61, negative 0.62. Here's negative 0.63 right here. So 0.2643. Get 0.7357. And that's the probability that a person selected at random has an IQ greater than 90. In part C of example 108, they're asking us to find the 33rd percentile for these IQ scores. Again, the mean, mu, is 100. And the standard deviation, sigma, is 16. We want the 33rd percentile, so that means we're going to find the x value, the IQ score. Such that 33% of the distribution is below it. And so I'm going to just sketch the curve here. %33% is below it. 33% is less than 50. Less than half is below it. So I know that this value has got to be to the left of the mean. So the mean, of course, is 100, has a z-score of 0, and the 33rd percentile, P33, we know that this area is 0.33. And we don't know yet what its z-score is, but I think that's one of the things we're going to be able to figure out first. We know an area to the left of this unknown value. Our table is perfect for finding a z-score if I know an area, right? I'm just going to search the sort of middle of the table to find the z-score, to find the area closest to 0.33, and then figure out what that z-score is. All right, so we know that our z-score is negative, right, because it's to the left of the mean. And I want to get as close to 0.33 as I can. And here we have 0.3300, so that's about as perfect as we could hope for. And that has a z-score of negative 0.4, and the column is in the 4 column, so negative 0.44 z-score associated with the left tail area of 0.33. So I know the z-score, and now I can use the z-score formula to figure out what the x value is. Here's our z-score formula, x minus mu over sigma. Now it's the x that's the unknown, so when I plug in the things I do know about this distribution, the z-score negative 0.44 is equal to x minus 100 over 16. And now we just have to do a little bit of algebra to solve this. I want to solve for x. I'm going to start by clearing denominators. I'm going to multiply both sides by 16. When I do this on the right side, these 16s cancel. And so I've just got x minus 100. And on the left side, 16 times negative 0.44 is negative 7.04. And to finish this up, all I need to do is add 100 to both sides. So on the right side, I've got x. On the left side, negative 0.704 plus 100 is 92.96. And that is our IQ score. So that's our 33rd percentile.